Measures of variation. Range of a data set. The range of a data set is given by the formula range equals max minus min, where max and min denote the maximum and minimum observations respectively. Example, determine the range. Each year, tornadoes that touch down are recorded. The following table gives the number of tornadoes that touch down during each month of 1 year. Our data set contains 2, 201, 70, 3, 92, 53, 54, 65, 102, 113, 80, 101. We want to find the range. Our largest data point is 201. Our smallest is 2. 201 minus 2 is 199. So that's the range of our data. While range is very easy to find, it's not always the most descriptive piece of information about our data. That's the sample standard deviation. For a variable x, the standard deviation of the observations for a sample is called a sample standard deviation. It is denoted S sub x, or, when no confusion will arise, simply S. The sub x only identifies different data sets. The defining formula is S equals the square root of the sum of x sub I minus x bar parentheses squared over n minus 1, where n is the sample size and x bar is the sample mean. To find the sample standard deviation, step 1, calculate the sample mean x bar. Step 2, construct a table to obtain the sum of squared deviations, which is the sum of parentheses x sub I minus the mean parentheses squared. Step 3, apply the formula to determine the sample standard deviation S. Example, determine the sample standard deviation. So using our tornado data, we want to first find the mean. So we need to find the sum of the data and divide by the number of data points. The sum of our data is 936. We have 12 data points. The sample mean equals 78. Next, we want to use the table to find the sample standard deviation. So for the table, we want to list all of our data points x. Second, we're going to find each data point minus our mean. Then we take each of our data points and square them. So what we're going to do, instead of computing all of that by hand, we're going to use our TI-84 calculator to assist us in this math. So going to our calculator, the first thing you want to do is go to Stat, Edit, for the menu, and number 1, edit. Enter. L1, we want to type all of our data. So I have 2, 3, 54, 113, 201, 92, 65, 80, 70, 53, 102, 103. I've made a mistake. It should be 101. So I'm going to use my left arrow so that the 3 is covered. I'll type 1. Note, it is in position 12 and I had 12 pieces of data. Enter. So now I have my data set. I know from earlier that my mean is 78. I'm going to arrow to the right so that I am now in L2. This is where I'm going to take each data point and subtract the mean. Instead of typing in 2 minus 78, then writing that number down, 3 minus 78, then writing that number down, and so on, I'm going to arrow up so that L2 is highlighted. Once L2 is highlighted, I'm going to type in L1. So second, 1, types in L1 minus 78, because that's what we found to be the mean. Then I press the Enter key, and it does all the calculation for us. So now I can take the information from my calculator, go back to my table, and type in all that information. The next thing I need to know in my table is x minus the mean parentheses squared. What that means is I need to calculate negative 76 squared, negative 75 squared, negative 24 squared, and so on. Heading back to my calculator, now what I'd like to do is find that information and put it in L3. I arrow to the right. I could type in negative 76 squared, enter, negative 75 squared, enter, and so on. However, if I highlight L3 by pushing the up arrow, then I can type in L2, which is second, 2, push the x squared button, enter, and it types in all the data for me. Now I can copy that to my table. Now that I've populated the column x minus the mean parentheses squared, I am ready to continue with my formula. I need to find the sum of my data point minus the mean parentheses squared, so I want to add up the third column. Heading to my calculator, I can get out of my list by pressing second, quit, and I'm back to my main screen. I want list, which is above the stat button, second, stat. I want to arrow over to math, and I want to use sum, which is number 5. Press enter, and the thing I would like to sum up is the third column of my table. So that's L3. Second, 3 types in L3 for me. I press enter, and I have a total of 30,494. The next thing I need to know is what is in. How many pieces of data did I have? We know that's 12. So in our formula, we need the square root of the sum of our data points minus the mean, parentheses squared, and n minus 1. We have 30,494 divided by 12 minus 1. We have the square root of 3,494 divided by 12 minus 1, or just 11. To get the square root on our calculator, second, x squared, and type in 30494 divided by, I'm going to use 11, enter, and I get 52.65151297. Rounding to 2 decimal places, I get 52.65 as my standard deviation. That tells me how much our data deviates from our mean of 78. Variation and the standard deviation. The more variation that there is in a data set, the larger is its standard deviation. Computing formula for a sample standard deviation. A sample standard deviation can be computed using the formula S equals the summation of x sub I squared minus the summation of x sub I squared divided by n all over n minus 1, where n is the sample size. This is just an additional formula that you can use to find the standard deviation. Example, Find the sample standard deviation for the given data. Round to the nearest hundredth, which is 2 decimal places. The normal monthly precipitation in inches for August is listed for 12 different U.S. cities. In our table, we have 3.5, 1.6, 2.4, 3.7, 4.1, 3.9, 1.0, 3.6, 4.2, 3.4, 3.7, 2.2. To find our standard deviation, we want to go to our calculator. In our calculator, we're going to go to Stat, Edit, Edit, Enter. I no longer need this data. One way to clear it is to arrow all the way up so that the L is highlighted, in this case L3. Press Clear, Enter. Arrow over to L2, up, clear, enter. Arrow over to L1, up, clear, then enter. Now I want to type in my data for the precipitation. So I have 3.5, 1.6, 2.4, 3.7, 4.1, 3.9, 1, and I've messed up, so I'm going to arrow up to the 3.9 and type that in again and press enter, and that's corrected my value. 1.0, 3.6, 4.2, 3.4, 3.7, 2.2, and I have my 12 pieces of data. Now I'm ready to find my standard deviation. This time, instead of creating a table, I'm going to press Stat again. I want to arrow over for the menu Calc. Under Calc, I want one variable statistics. Enter. Some of you will see a menu that looks like this. Our list we do want to be in L1. We do not have a frequency list, so that needs to be blank. We're ready to calculate, so arrow down. Once calculate is highlighted, you press enter, and it gives you this lovely set of data. The data point that we're looking for is the sample standard deviation, which is Sx. When you write this down, you need to label it as S equals. We don't want to copy just what's in the calculator. So for S, we have 1.0457. Some of you, when you went from your list view to Stat over to Calc and chose one variable statistics, your screen looked like this. I can either hit enter, or I can type in second L1 to tell it what list to use, enter, and then I get the same information. My S of X is also 1.045734482. We want to round to 2 decimal places, so S equals 1.05 inches. Grouped data formulas. X bar equals the sum of X sub I times F sub I divided by N, and S equals the square root of the sum of X sub I minus X bar parentheses squared times F sub I divided by N minus 1, where X sub I denotes either class mark or midpoint. F sub I denotes the class frequency, and N equals sum of F sub I denotes sample size. The sample standard deviation can also be obtained by using the computing formula. S equals the square root, in the numerator, sum of X sub I squared times F sub I minus parentheses sum of X sub I times F sub I close parentheses squared divided by N, and in the denominator n-1. Example: estimate the mean and sample standard deviation of the data set. The results of a random sample of the number of computers per household in a region are shown in the histogram. The number of computers, 0. The number of households, 6. That means we had 6 results that had 0 computers. For 1 computer, 5 households. 2 computers, 13 households. 3 computers, 2 households. 4 computers, 4 households. Looking at our formulas for the mean and the standard deviation, we are going to have to find the mean first. Setting up a table, our first step is to put the data in, then its frequency. Then we want to find the data point times the frequency. In my calculator, I want to go to the Stat menu, Edit. I'm going to arrow up and clear to get rid of my data for L1. Now I want to type in 0, 1, 2, 3, 4. Then I want to go over to L2 and type in my frequency, 6, 5, 13, 2, 4. Then I'm going to go over to L3, arrow up, because I want to multiply x times its frequency. So L1, which is second 1, times L2, which is second 2. Enter. So now I want to add that to my table. I'm ready to find my mean. I need to know 2 things to find my mean: the sum of this column and the sum of my frequency. Going back to my calculator, I want to get back to my main screen, so second and then mode allows me to quit. I want my list, second, stat. I want to go over to math, choose sum. I can just press 5. Second 2, we'll type in L2. When I press enter, I will have my total frequency of 30. Now I want to find the sum of the column XF. I can press second, then my enter key, and it will retype the sum of L2. I can arrow to the right. I want L3, which is second 3. Enter, and I get 53. So dividing 53 by 30, I get 1.8 when I round to the first decimal place. Now that I know the mean, I can find my next column, which will be my data point minus my mean. So far, what we have is x in L1, my frequency in L2, x times f in L3, and I'm going to find x minus the mean in L4. Stat, I want edit, enter. I'm going to arrow over to L4, highlight L4. Second 1 types in L1 minus 1.8. Enter. And now I have x minus the mean. I can add that to my chart. And now I'm ready to take that information and square it. In my calculator, I want to go over to L5, arrow up, because I need to square L4. Second 4 types in L4. The x squared button types in the square. enter, and now I'm ready to add that to my table. The last step is to multiply these answers by the frequency. So again, I have L1 is my X, L2 is my F, L3 is X times F, L4 is X minus the mean, and L5 is X minus the mean squared. The two pieces of information I would like to multiply are in L5 and L1. Now that we're at our calculator, we want to arrow up to L6. I want to multiply L2, so second 2, times L5, second 5, enter. And now I have X minus the mean, parentheses squared, times the frequency. In my table, I add that information. In order to use my formula for the standard deviation, I need to add up that last column. I already know that my total frequency is 30, so I have N. Calculating, second, and mode to quit this menu. This time I want to sum L6. Second, enter. Arrow over. Second, 6 gives me L6, enter, and I get 45.4. And now I'm ready to use the formula. I need to find the square root of 45.4 divided by 30 minus 1, which is 29. So we type in square root, second, x squared. Then we want our answer, second, negative, which types in A and S. Then divide it by n minus 1, which is 29. Enter. I have 1.2512. Gives me 1.25 when using two decimal places. 3 standard deviations rule. Almost all of the observations in any data set lie within 3 standard deviations to either side of the mean. Example, find the standard deviation, round to 1 decimal place. The manager of a bank recorded the amount of time each customer spent waiting in line during peak business hours one Monday. For a waiting time in minutes of 0 to under 4, the number of customers was 10. 4 to under 8 was 15. 8 to under 12 was 15. 12 to under 16 was 8. 16 to under 20 was 0. 20 to under 24 was 2. To find the standard deviation, we first have to find x. X is going to be the midpoint of our waiting time. Even though this is cutoff data, we can still find the midpoint by adding the two numbers and dividing by 2. 0 plus 4 divided by 2 is going to give me 4 over 2, which is 2. 4 plus 8 divided by 2 is going to give me 12 over 2, which is 6. 8 plus 12 is 20, divided by 2 is 10. 16 plus 12 is 28, divided by 2 is 14. 16 plus 20 is 36, divided by 2 is 18. 20 plus 24 is 44, divided by 2 is 22. So now I'm ready to use my calculator to help me find the standard deviation. I'm going to type x in L1 and the frequency, number of customers, in L2. Pressing the Stat button, We want one edit, enter. And I have a lot of data in here. One way I can get rid of it is by pushing second, then plus, which is the memory. The fourth one down is clear all list, enter, and it is done. So when I go to stat, edit, my lists are empty. I'm going to arrow over. In L1, I'm going to type all my values for X, the midpoints. 2, 6, 10, 14, 18, 22. Then I'm going to arrow over to L2 and type in my frequency. 10, 15, 15 again, 8, 0, and 2. This time, instead of filling up my L3, L4, L5, and L6, I'm going to click on Stat again, arrow over to Calc, choose one variable statistics, enter. I want my list to be L1, arrow down. This time my frequency list is in L2. We actually have frequencies this time. So second 2 gives me L2, arrow down, press enter for calculate. If I needed it, I would have the mean right here, 8.32, and my sample standard deviation is right here, 4.854789.346. We will round it to one decimal place. However, not all of you saw the menu that I just demonstrated. For those of you that have a TI-83 or an older TI-84, you type in the data for L1 and L2, pressed your stat button, arrowed over to calc, pressed enter, and you got something that looked like this. We still want it to consider L1 and its frequency L2. So we want to type in L1, which is second, 1. We want to use the comma, which is above your 7. Second, 2, which is L2. So we have to tell it what two columns to look in. Then when we press enter, we get the same standard deviation of 4.854789.346. And rounding it to one decimal place, we should get 4.9. To recap the section, measures of variation, range of a data set. The range of a data set is just taking the largest data point and the smallest data point and subtracting them. Sample standard deviation, which tells you how much the information varies from the mean. We can find our sample standard deviation by using the formula or using the computing formula for the sample standard deviation, or we can use our calculator. The 3 standard deviations rule lets us know that most of our data will be within 3 standard deviations of the mean.